Um, in this video, I'm going to discuss the topic on influence lines. Influence lines have important application for the design of structures that resist large live loads. So example, bridges. Yes. In this topic, we will discuss how to draw the influence line for a statically determinate structure. The theory is applied to structures subjected to a distributed load, uniform distributed load, or a series of concentrated forces, and specific applications to floor girders, beams, and bridge trusses. If a structure is subjected to a live or a moving load, the variation of the shear and bending moment in the member is best described using the influence line. An influence line represents the variation of either the reaction, shear, or moment at a specific point in a member as a concentrated force moves over the member. So, ang assumption na is the load will move from left to right. And every time we move ang load, unit load, ga-change po ang value sa reaction, shear, or moment. So, using influence line, makita mo ang change sa iyang value every time mo move unit load. So, once this line is constructed, one can tell at a glance where the moving load should be placed on the structure so that it creates the greatest influence at the specified point. So, mura sa visual aid, di ba? Makita na rin mo kung asa mo gusto ibutang ang unit load so that you will attain maximum or you will get maximum value. And so, procedure for analysis. Either of the following two procedures can be used to construct the influence line at a specific point P in a member for any function. So this is for beams, reaction, shear, or moment. Sa truss, reaction support, o force ng member. Okay, so, kani atong gamiton. Duha ka procedure. So the first one is to tabulate values. So, unsaon, inani sa. First, you place a unit load at various locations. Depende sa increment. So, ikaw magpili. You choose kung pila yung increment by 1 meter ba, by 1 foot ba. At various locations, X along the member, and at each location, use statics to determine the value of the function at the specified point. So at each location daw. So every time mag-move ang unit load, use statics, meaning to say, use the conditions of equilibrium, either summation of moment or summation of force, to determine the value of the function at the specified point. Function either reaction, shear, or moment. Yan. So, sa sample problem, ma-discussion. If the influence line for a vertical force reaction at a point on a beam is to be constructed, consider the reaction to be positive at the point when it acts upward on the beam. So, remember this. Kung reaction imong kaan og influence line, positive siya kung upward. If a shear or moment influence line is to be drawn for a point, take the shear or moment at the point as positive according to the same sign convention used for drawing shear and moment diagrams. kana siya for shear and moment. So, kining sun convention used for drawing shear and moment diagrams, we all know nga sa shear and moment in beams na every time mo cut ka og section and then you analyze the left side, ang shear nimo, positive shear is downward, positive moment is counterclockwise. But if you analyze the right side, shear is upward, moment is clockwise. Mo na siya atong positive nga sign convention. Same also atong gamiton sa shear and moment influence line. And all statically determinate beams will have influence lines that consist of straight line segments. So, tanan dire, puro straight line. Basta statically determinate. Pag indeterminate na curved line, dili na siya straight. So, after some practice, kung medyo familiar na kayo ka, one should be able to minimize computations and locate the unit load only at points representing the endpoints of each line segment. So, anad na ka, familiar na kayo ka, pwede na nimo ma-minimize yung computations because dire, kini na procedure is tabulate kag values. Therefore, you will have so many values of x. Like kung nakay length nga 20 meters, nya tag 1 meter yung interval, di ka 20 sad ka magbutang or 20. Pero kung anad na ka, familiar na ka, minimize na nimo. So, you can just locate the unit load at points representing the end points of each line segment. Sa tumoy-tumoy, wala na in between sa duha ka points. End points naman. The second procedure is using equations. So equation natin. The influence line can also be constructed by placing the unit load at a variable position x on the member and then computing the value of the reaction, shear, or moment at the point as a function of x. Mas dali ni siya. Okay. So in this manner, the equations of the various line segments composing the influence line can be determined and plotted. So na naman ka equation, ma-plot na nimo. You can just use 2 points niya, i-connect nimo sa na naka-line din. So for now, we will skip the loadings. Kaya in this part, our focus is on the construction of the influence line. So illustration, to illustrate the two procedures, so let us solve this one. Draw the influence line for the reaction at A for the beam shown. So you have a 10-meter simple beam. So first procedure is to tabulate the values. So you have this beam and RA lang tano kay ang paa na to is influence line man sa reaction siya. Nya i-divide na to tag 1 meter atong interval. 1, 2, 3, 4, 5, 6, 7, 8, 9. So bali ang buhatan na ni, magtabulating values is, you place the unit load at A first and then move nimo 1 meter until it will reach point B. And every time mag-move ang unit load, i-compute nimo o i-determine nimo ang value sa RA. Like kung ang unit load is at this point, 3 meters from A, what's the reaction at A? Use statics. So you sum up moment about point B, makuha mo RA. Imo na i-tabulate. So inani siya. So first, dili sa A, no? Doon sa kag-light. Naka-unit load niya. Naka-table din dire. So at point A, x is 0, we all know that RA is equal to 1. Okay. Diretso na siya. value ni automatic reaction. Next is i-move din mo dire. Oh. Ano siya 1? Move x equals 1, use statics. I mentioned the moment at B, 1 times 9 minus RA times 10 equal to 0. And you have RA equal to 0.9. So, i-plot na sa dani mo, 0.9. And then move x equals 2. And then use statics again. So, I mentioned the moment sa B. And you have RA equal to 0.8. Plot nimo. You do the same until you will reach point B. So, ano siya? Ano, no? So, sige lang, move. Until you will reach B. So, at B, x is equal to 10. Kaya ang reference na to is A man. And at B, we all know that RA is 0. Kaya ang RB na is 1. So, 0 na. And then, i-connect na mo. Okay. This is now the influence line for the reaction at A. So, procedure number 2 is use equations. So, ano yan ba ito? You have this beam, then you place the load at an arbitrary point where distance is equal to x. And kuhanin mong RA as a function of x. What you will do is you sum up moment at B, like this one, and 1 times distance 10 minus x minus RA times 10. You have RA na 10 minus x over 10, or i-divide mo, you have 1 minus x over 10. So i-plot mo, and you can just use 2 points. You'll just use A and B. So at A, x is 0. At B, x equal to 10. Okay, so this one. When x is 0 for RA, when x is 0, RA is 1. And at point B, x is 10, RA is 0. And then just connect. And you can see this influence line is the same as this one. So for example, if x is given, like when x is equal to 4, what's the value of RA? So for the first procedure, nasa table na when x is equal to 4, RA is 0.6. But when using equations, you'll just substitute x. So when x is 4, 1 minus 4 over 10, the answer is 0.6. Same lang. Same lang sa lahat. So, for the other problems, we will focus on the equations. Time-consuming ang pag-tabulate of values. Although, sayo na rin siya gamiton, pero time-consuming. Okay, so ang focus na to will be on the equations. Now, same problem, but this time, we are going to draw the influence line for the shear and bending moment at C for the beam shown. So, kung mag-draw tag shear and mag-draw tag influence line for shear and moment, you remember this, you will have two equations for shear. Okay? Two equations. One equation when the unit load is before the point, and then one equation when the unit load is after the point. It already passes point zero. So okay. So here's the solution. First, the unit load is before point C. So can so another unit load, and then shear sa C, moment sa C. Okay, same man sa shear moment diagram. And then RA. Ang atong RA, 1 minus x over 10. Nasolve naman na dyan. 1 minus x over 10. By the way, sa influence line, for a simple beam, you only have one equation for reaction. But for compound beams, depende po. So, kung naka-compound beam na duha lang siya kabuok, duha lang ka beams connected by a single hinge, then you will also have two equations for the reaction. Pag compound beams po na tulo sila kabuok, tulo ka beams joined by two internal hinges, then you also have three equations for reaction. Okay. So for simple beam, two equations for shear and moment. That is one before the point, and another one is after the point. So again, you have this reaction, and use statics para makuha nimo ang shear or moment as a function of x. Summation of force sa y, you have this, and summation of moment. You simplify, you'll get this one, mc equal to 0.6x. And then the other one is when the unit load is after point C. So pag after na sa point C, ang unit load na din na side daw. So like this one. Ato lang butang si baba, although dire na siya, pero para dili siya gubot. Butang na to si baba. So shear at C, moment at C, reaction. Okay, ang difference ni is this time, wala na unit load makita. O kaya lapas naman siya sa C. And you are analyzing the left side of the cutting section man. So wala na unit load makita din. So when you sum up forces along the vertical, you only have two, RA and VC. Wala na ang unit load. So VC is 1 minus x over 10, and moment, wala na sa moment sa unit load. Okay. So since you have the equations na, pwede na ka ma-plot. Plot na nimo. So influence line for shear at C. Okay. Kining equation is from E to C nisa, meaning ang x nimo 0 to 4. So gamito nimo when x is 0, 0, diba? And when x is 4, that's negative 0.4. Mo ni siya. 0 tapos negative 0.4, i-plot din nimo. Diba? And then this equation is valid for x from 4 to 10. There man C to B, so 4 to 10. So when x is 4, 1 minus 4 over 10, it's 0.6. And when x is equal to 10, you have 0. So 0.6 to 0. Ano yung diagram? 0.6 na. And for moment, pwede nyo i-join, pwede na sa dili. Okay, so for moment, this equation is for x from 0 to 4. And for this one, x from 4 to 10. So when x is 0, 0 a moment. When x is 4, that's 2.4. So this one, 2.4 na. And then there, when x is 4, that's 2.4. And then when x is 10, it's 0. So draw lang ka the line. Okay, so mo ang influence lines sa shear and moment. Okay, the next one is a compound beam. Compound beam. So duha ka beams, EBCD, and another beam, DE. connected by a hinge at D. Okay. So, given the compound beam as shown below, construct the influence lines for RA, RC, RE, shear at B, and moment at B. So, as I have said a while ago, for compound beams, since duha ni ka beams, duha sa datong equation sa reaction. Bali, first equation is before sa hinge, ang unit load. Another equation if the unit load is after the hinge. Okay. So, solution, reactions, first condition, unit load before the hinge. So, you have this one. So, kung before sa hinge, it doesn't matter if the unit load is in between A and B, between B and C, or between C and D. Dili mag-matter for as long as before siya sa hinge. Okay, example, nasa diri sa CB. Ang distance niya is X. X raman god. Maski ibutang mo diri sa EB, X raman gyapon eh. Or sa BC, X lang gyapon yung distance. So, going back to beam analysis, what will you do with this? Para makuha nimo ang reactions. Of course, you have learned na pag compound beam gani, ang buhaton nimo is cut kag section, cut ka sa hinge, and then you isolate the part with only one unknown reaction. So in this case, it's the right one, right portion. So pag-cut sa D, analyze the right, your unknown is only RE. So yun na nila. Of course, you have three reactions, RA, RC, and RE. So, dali to analyze na segment DE, kata diha. Okay, mo niya. Natay RA. And we all know nga kung hinge, moment is 0. So, we could sum up moment at D and solve for RE na 0. Okay. And then after this, you consider the whole beam. In whole beam ka, na naman kay value sa RE ha. You can sum up moment at A and you can solve for RC. On. So RC times 4 minus, take note, 1 times X. So regardless sa position sa unit load, whether dire, BC or AB, still ang yung distance is X ay gawon. So natay RC na 1/4 or 0.25X. And then sum up pag force sa Y, makuha mo ang RA. Nanama kay RC. Then RE 0. Inana kay RA na 1 minus 0.25X. The second one is when the unit load is after the hinge. Ano? So, X area po yung distance. Same procedure lang. Nakay tulo ka reactions. Cut ka sa D and analyze the right part. Okay. This distance is X minus 7 kay X man eh. Tapos 7 na, 2 plus 2 plus 3. So this is X minus 7. And sa after moment sa D, and you have this RE, X minus 7 over 3. And then after this, consider the whole beam again. You sum up moment at A again, and masolve mo ang RC. Okay. Mo ng RC. 70 minus 7X over 12. And then after that, to solve for RA, sum up force along the vertical. And you have this RA. Okay, now, for shear and moment at B, okay. Sa previous sample, for a simple beam, you have two equations for shear and moment, di ba? One is before sa cutting section, another equation after the cutting section. Now, for compound beams, plus 1, you will have an additional equation. So, originally, pag simple beam, duha, na compound beam man plus 1, naka 3 na. So, you will have 3 equations for shear and 3 equations for moment. So, kung unsaon, inani sa. Since our function, ang function nato is shear and moment at B, influence line na ninduha, dili ta mag-cut sa B, point B ta mag-cut, no? So, kung saan pag-cut sa B, sa pag-cut sa B. Ang condition sa ani is inani. Unit load before sa B, one equation. Another equation, unit load after point B, but before the hinge. And then ang third one is after sa hinge ang unit load. Yan na ito condition. Like this one. Unit load before point B. Cut ka diha, and then another unit load at a distance x. Shear, and then moment. This is your RA, no? Kini yo? Okay, kini siyang RA is when the unit load is before the hinge. Take note ha? Before the hinge. Valid ni siya nga RA pag before sa hinge. So, before point B man, before pa man sa hinge, therefore, ang atong RA is 1 minus 0.25. Pag after na sa hinge, kini na sila itong RA. So, before sa hinge, point B, use statics, dimension of force sa Y, this is VB, and then summation of moment, that's MB. Okay? And then, okay, after point B, but before the hinge, before the hinge. So, ang RA na to as is lang. Pero ang point is after na sa point B. So, shear moment, ang reaction na to, same lang. Kay before sa hinge man happen. So, use statics, na kay VB, and then sa upward moment, mo na imong moment sa B equation. And then the last one, unit load after the hinge, mao na siya. Another ang load na to after sa hinge. Shear, moment. Ang reaction na to, na raw, x minus 10 over 4. Okay? Muna siya itong reaction. So, use statics, solve kag VB, and then sa kag moment, na kay MB. Okay, so complete na yung equation, pwede na mo draw sa influence line. So let's recall, for reactions, duha ka case, unit load before sa hinge, and then unit load after sa hinge. Muna equations before sa hinge. Let's check. Muna no? RA, RC, o RA. Muna siya. Tapos unit load after sa hinge, kana silang tulo. Kene, no? After sa hinge, RA, RC, RE. And then, shear moment sa B, before sa point kene, negative 0.25 and 0.5. And then, after sa point B, o after sa hinge. Nadal. Okay. So, ready na tayo ma-plot, no? Plot na to. So, RA. Duha lang ni sa duha. One equation before sa hinge. Bali, isa lang ka line from A to D. And then another line from D to E. After the hinge naman, D to E. So, 2 lines only. Kaya duha lang mo kaya equation. So, sige, RA. When x is 0, 1. Eh? And then, we will not include B, C, dala, A, C, D, E. At C, x is 4. So, 1 minus 0.25 times 4 is 0. And at D, x is 7. 1 minus 0.25 times 7, it's negative 0.75. And then for DE, this equation, when x is 7, negative 3/4 or negative 0.75. When x is 10, 0, 0. Tapos i-connect ni mo. Okay, na. And then for RC, same lang. One line for one line for ABCD and another line for DE. 0.25x. So when x is 0, 0. When x is 4, that's 1. When x is 7, that's 1.75. And then for this one, when x is 7, 1.75 we all gihapon. And when x is 10, 0 na. So connect. And then for RE, 0 siya. For ABCD, 0, 0, 0, and then 0 there. And for DE, that's x minus 7 over 3. So when x is 7, 0. When x is 10, 10 minus 7, 3 divided by 3, 1. And then i-connect nyo. Okay? And then for shear at B, you will have 3 lines. One line from E to B before sa point. Another line from B to D. Bali after sa point B but before the hinge. And another line for DE. So just substitute values of x. So, negative 0.25 when x is 0, 0. When x is 2, negative 0.5. Okay. Yan na. Oh. And then this is from 2 to 7. When x is 2, that's 0.5. And at C, when x is 4, that's 0. And at D, x equal to 7, 1 minus 0.25 times 7, it's negative 0.75. And then for DE, when x is 7, negative 0.75. When x is 10, 0. So connect kana, and then this one, kana, and then this one. And for moment at B, same lang, 0 to 2, 1, and then 2, 4, 7 na x, 2, 4, 7, and then 7 to 10, and then connect nyo. So this is the answer for the given problem. Last one. The figure shows a compound beam. Draw influence for RA, RB, MB. Shear sa D, moment sa D, shear sa E, and moment sa E. Okay? So, for the reactions, duha na eh. Kaya duha mo ni ka beams, EC and CB. Okay. So, okay, unit load before RA, RB, and then MB. Unit load before sa hinge, butang natong load, yeah, X. And then procedure is cut ka sa hinge, analyze the portion with only one unknown. So in this case, left side. So, segment AC, and butan mo load, distance X, and then sa pag-moment sa C, makuha ni mong RA. You have RA equal to 4 minus X over 4. And then after that, you can sum up force sa Y to solve for RB, or you can sum up moment at B. So, summation of moment at B, ano siya? Negative RA times 8. This is RA, no? Negative RA times 8 na unit load 1. 8 minus X, and then MB. So, simplify. The result is MB equals negative X. And then, summation of force sa Y, makuha mo ang RB. After the hinge, so RA, RB, and MB, ang load na adere, after sa hinge, distance X, same yung decision niya po, cut ka sa C, isolate segment EC. Wala na kay load makita, no? Kaya, naram siya din sa gawas, after sa C. No? So, yung sum up moment at C, RA is 0. And then, whole beam, ha? Sa pag-movement sa B, makuha ni mo. And then, that's MB. And then, summation of force sa Y, makuha ni mong RB. 1. So, shear and moment at D ka. So, 3 equations. One equation before sa D. Second, after sa D, but before the hinge. Third one is after sa hinge. So, unit load before point D. Sige. Now, take note ha, ang function mo kay shear and moment at D. So, dili ka mag-cut sa D. Regardless sa position sa unit load, dili ka mag-cut sa D. Sige. So, this is your RA. Mamuna itong RA, no? Before sa hinge na, before sa hinge. So, muna itong RA. So, nada unit load, distance X, shear o moment, use statics, sa pag-force sa Y, naka-shear sa D, sa pag-moment, naka. And then, sorry, this is point D. Unit load after point D, but still before the hinge. So, before the hinge man, ang reaction ng mga gamit mo, same lang yapon. Kana lang yapon kay before the hinge man. But ang unit load is already after point D. D sa D. Lapas na sa D. Shear moment, yung equation mo, kana summation of moment. And then the last one is after the hinge na. So this time, ang reaction mo lahi na after naman sa hinge. 0, tanada, mo naman ino. Unit load after the hinge, ang RA nimo is 0 man. Mo na yung gamiton na. RA equal to 0. So ang unit load na dire after na sa hinge, shear of moment, sa pag-force, shear 0. Sa pag-force, sa pag-moment, moment 0. And then last is sa E, function mo, shear and moment at E. So, mao ni sa. This time, kung sa E ka, ang condition mo, one equation before sa hinge, second, after sa hinge but before point A. And then third one is after point A. Kaya diri makamagka. So, wala ni kwenta ni D diri. So, una, EC before sa hinge, then C to E, and then E to B. Mga na yung condition. So, since ang function na to, kay shear moment at E man sa E siya magkata. Okay. So, mo na itong RA kay before man sa hinge. Take na ta, before sa hinge ang condition. So, okay. Nada unit load, and then shear of moment, use statics, force sa Y, na kay shear, and then sa moment, just simplify, mo ni makuha nimo. Okay? And then second, after sa hinge, but before point A. So, dili nga side na. Dili nga portion. Ang RA na to, 0 na kay after naman sa hinge, di ba? 0 man eh. Basta after sa hinge. Another unit load, and moment, shear of moment, and then yung statics. Na kay shear na negative 1, moment ni mo, x minus 6. And then last, after sa point E, ang reaction ni mo 0 agyapon kay ang point E kay after naman sa hinge. So kini ang reaction ni mo gamiton. Nandiyan unit load no? After na sa E. Kumbaga, wala na kayo makita na load dire. So summation of force sa Y, shear is 0, kaya wala 0 man gapon eh. And same also with moment 0. So complete na, pwede na ito ma-plot. So recall lang na to equations. Unit load before sa hinge. Kini. Before sa hinge na. Unit load after sa hinge. Dire. RA, RB, MB. And then shear and moment at D. Kini. Nara. And then after D, sorry. After D, and after sa hinge, this one. 0, 0. And then last is shear and moment at E. Before sa hinge, after sa hinge, but before E, and then nana there. And then after it. So, pwede ka mo plot. Plot nimo. For RA, two equations. Kini na equation, before sa hinge man, so valid na from E to C. So, ang X nimo 0 to 4. Pero pwede ra 0 to 4. No? Ato ay disregarding D. Ha? Siya shear ag moment na natin i-consider. So, for reaction, ECB lang. So, when X is 0, is 1. When X is 4, that's 0. And then, for CB, 0 naman yan. So, 0 sa nidire. And then, connect. Inana. And then, for RB, when X is 0, 0. When X is 4, you have 1. And there, 1, yapon. 1, at anong constant ba? 1, 1, 1. So, connect. For MB, it's negative X. So, 0, when X is 4, negative 4 po siya. 0, negative 4 po. And then there, when X is 4, that's negative 4. When X is 8, that's 0. So, mo ni mo diagram. Influence line. And then here's a D. 3 line segments. 1, 2, and 3. This one is from E to D, 0 to 2. So, kana, no? When x is 2, it's negative 0.5. Dili na yun, 2 to 4 na siya. After sa B, after sa D, rather, niya before sa hinge. When x is 2, that's positive 1 half. And when x is 4, that's 0. And then sa ikatulo, shear ni mo 0 na. So 0, 0, 0. So i-connect ka na. And then kana dayon. And then straight line, horizontal. Pwede mo i-close, pwede rin po dili. For MD, three equations, three line segments. X0, 0, and x equal to 2, that's 1. And then when x is 2, 1 also. When x is 4, that's 0. And then 0 na said na 0, 0, and 0. So line, and then line. And then she's a E, negative 0.25. So, kini ha, before sa hinge ni, so 0 to 2 na siya, 0, and then before sa hinge man. So, ato lang skip ni D. Bali ang ato karon is EC, CE, and EB. So, when x is 4, that's negative 1. And then, dire, from C to A, negative 1. So, negative 1 there, negative 1 sa na. And then, after sa hinge, after point A rather, 0 na. So, 0 na, 0 sa dali. So, straight line, and then horizontal, and horizontal. And then last, moment sa A, negative 0.5. When x is 0, 0. When x is 4, that's negative 2. And then dire, when x is 4, negative 2. When x is 6, 0. 0 na. And then last, 0 na, constant 0, 0. And then you connect, and then pana, and then. So these are the influence lines for the given problem. Mone resulta if you are using equations in plotting the influence lines. So I hope that you have learned something. Thank you for watching.